Hello dear students. So let us continue with conductometric titrations where we stopped in our previous class. So we discussed two cases of conductometric titration. So that was, the first one was strong acid against a strong base, and the second one, so weak acid against strong base. Okay. So I need not to explain about what we discussed in our previous class, because the same thing we are going to discuss in this class. Okay, so I will be explaining the same thing, only there will be the difference in the graph, that's all. So let us start with today's session only. Today we will see how the conductometric titration of strong acid against weak base is carried out. Okay, so now strong acid means we all know that hydrochloric acid is a strong acid, and a weak base is ammonium hydroxide. So ammonium hydroxide is the example for a weak base. So what is the principle involved in this conductometric titration is, so to understand that, so let us pipette out HCl to the beaker. Okay, so here HCl is pipetted out and it is titrated against ammonium hydroxide. So what happens here is, since HCl is a strong electrolyte, so the initial conductance will be very high. So before adding titrant to it, that is ammonium hydroxide to it, if we measure the conductance of hydrochloric acid, since hydrochloric acid is a strong acid and a strong electrolyte, so the conductance is very high. So that is why we are going to start the graph from here. Okay, so the conductance will be very high. Next, as we proceed with our titration, as we continue adding ammonium hydroxide 1 ml to the hydrochloric acid, what happens is the strong electrolyte hydrochloric acid reacts with ammonium hydroxide, and it is replaced by salt, what is called as ammonium chloride, that is NH4Cl. Okay, so this is what the reaction is going to take place in this titration. That is, when hydrochloric acid is titrated with ammonium hydroxide, so there the ammonium will get replaced with chloride ions and water will be eliminated. HCl plus NH4OH will give rise to NH4Cl plus H2O. Okay, so this is the reaction what is going to take place in this particular titration. So during the titration, the conductance of the solution is going to get decreased. So that is why we are observing a slope or a straight line which is in the decreasing order. Okay, so until the equivalence point, as the fast moving H plus ions are replaced by slow moving NH4 plus ions, so we are going to get the decrease in the conductance. Once after the equivalence point is reached or the end point is attained, what happens here is the ammonium hydroxide is going to get accumulated. Okay, accumulated means, so there is no hydrochloric acid left to react with ammonium hydroxide. So all the hydrochloric acid has been converted into ammonium chloride. So that is why if we continue adding ammonium hydroxide to the beaker and measure the conductance, since ammonium hydroxide is a weak electrolyte, so we will observe constant conductance which is observed in the measurement. Okay, so the conductance of the solution practically will remain constant. So that is why, so here we are getting a straight line which is in a constant manner. Okay, so this is how we are going to perform the experiment. And once after noting down the conductance what has been measured by adding 1 ml, 2 ml, 3 ml, 4 ml, 5 ml, 6 ml like this, so we have to plot the graph. So on plotting the conductance of the solution against the volume of ammonium hydroxide added, so we are going to get two straight lines, and the point of intersection gives the end point. Okay, so this is the point of intersection and this gives the end point of the titration. Okay, so the procedure is same. So if you check it in your textbook, so the procedure will be same for all the cases. So 50 ml of the hydrochloric acid will be pipetted out into the beaker, and to that a clean conductivity cell is dipped, and the conductance measurement of 0 is measured. Okay, so first we have to measure 0th conductance value is very important. From there only graph is going to take place. Okay, so before adding any titrant to it, in this case before adding ammonium hydroxide, we have to measure the conductance. So that will be the initial conductance of the electrolyte, and next we have to add 1 ml of ammonium hydroxide, that is one normal of ammonium hydroxide is taken, and we have to add 1 ml in a successive amounts of ammonium hydroxide, and the measurement of conductance is repeated until at least 3 or 4 readings are obtained after the end point. Okay, so after the end point we should take at least 3 or 4 readings, and then we are going to plot the graph by measuring the conductance in the y-axis and pointing out the volume of NH4 OH added in the x-axis. Okay, so the point of intersection will give the end point of the titration. So this is the third case which we are studying in conductometric titration, and the next fourth case is conductometric titration of weak acid against weak base. Okay, so to perform this titration I am taking acetic acid and ammonium hydroxide. So here in the previous we saw, so this is weak acid, acetic acid we have used, and this is weak base, so ammonium hydroxide we have used. So in this we are using weak acid and weak base, both are weak. Okay, so weak acid against weak base titration is going to be studied in case 4. So to study this, what I am going to do is, so I am going to pipette out acetic acid into the beaker and I am going to titrate it with ammonium hydroxide. Okay, so since acetic acid is a weak acid, its initial conductance will be low. Okay, so that is why the graph is starting from here. Okay, so we have a slope which is increasing, that means the straight line is increasing. How it will increase? So how it will increase means, once after taking acetic acid in a beaker and titrating with the sodium hydroxide, what happens is, so we are going to get a strong electrolyte, that is a salt of ammonium acetate. Ammonium acetate is formed. Okay, so that means, so here the H, this acetic acid is going to get dissociated into CH3COO minus and H plus. Okay, so here the H plus is replaced with NH4. So then what happens? CH3COO NH4, that is a salt of ammonium acetate, and ammonium acetate is a strong electrolyte. What does it mean? A strong electrolyte means, so it carries current in a faster way or in a smoother way compared to the acetic acid. Okay, so acetic acid is a weak electrolyte, and ammonium acetate, which is going to get formed during the titration, is a strong electrolyte. So that is why we are going to see the increase in the conductance. Okay, so how far it is going to increase? So it is going to increase till it attains the end point. Okay, so when all the H plus which is present in the acetic acid is replaced with the NH4, so then the ammonium acetate is formed. Once all the acetic acid is converted into ammonium acetate, so what happens if we continue the titration? So the NH4OH, that is ammonium hydroxide, is going to get accumulated. Okay, so next there is no acetic acid left to react with ammonium hydroxide, so that is why what happens is NH4OH is going to get accumulated, and since ammonium hydroxide is a weak electrolyte, so the conductance which is measured will remains constant. Okay, the conductance practically remains constant when NH4OH is accumulated. Okay, so on plotting the conductance of the solution against the volume of NH4OH added, we are going to get two straight lines with the different slopes, and the point of intersection gives the end point. Okay, so the procedure is same how I have explained in the previous case. We have to take 50 ml of acetic acid in the beaker and we have to titrate it with ammonium hydroxide. Okay, so and once after the end point is reached, so we have to repeat the titration by at least adding 3 or 4 ml of ammonium hydroxide, and then a graph is plotted. So by taking ammonium hydroxide added in the x-axis and the conductance measured in the y-axis. So we are going to get the end point. Okay, so this is case 4. And the next is very important. So this is very important. Why? Because so this is what experiment you are going to perform in your next semester, and it is from the exam point of view also very important, because the 3 instrumentation experiments will be given to you in the next semester. Instrumentation under physical chemistry experiments, that is, one will be the measurement of conductance, that is conductometer experiment, and the second potentiometer experiment will be there, potentiometric titrations, and the third one calorimetry. Okay, so calorimetric estimation of copper sulfate will be there. So this conductometry titration, that too especially a titration of a mixture of acids against base. This is the experiment what you have got in your syllabus. Okay, so listen to it in a careful way. So here what we are going to do is, first we are going to prepare a mixture of acid solution. Okay, so the mixture of acid solution will be given to you, and you will be not knowing what is the concentration of each acid. Okay, either you will be given a mixture of hydrochloric acid and acetic acid, and both the concentration is unknown to you, and you are asked to determine the concentration of a mixture of acids. Okay, so that is the experiment what you will be having. So now let us take a mixture of acids pipetted out to a beaker. Okay, so we are going to pipette out acid mixture to the beaker, that is hydrochloric acid and acetic acid, and it is titrated against NaOH. Okay, so NaOH is taken in the burette and acids are taken in the beaker. Okay, so due to the presence of hydrochloric acid, since hydrochloric acid is a strong electrolyte and it is a very good it is having a very good conductance property, so the initial conductance will be very high. Okay, so this is due to the presence of hydrochloric acid. So since it is a strong electrolyte, so this is going to react first with the sodium hydroxide. Okay, so HCl is going to react first. So what happens? So all the HCl is going to get replaced with the sodium chloride. That means, so here the H plus ions are going to get replaced with the Na plus ions, thereby converting this hydrochloric acid into a salt form, which is called as sodium chloride. Okay, so since sodium is a slower moving ion compared to H plus, so that I have already given explanation in my previous class, sodium will move slower compared to hydrogen, so that is why so the conductance gradually goes on decreasing. Okay, so the conductance will go on decreasing. So how far the conductance is going to decrease means till all the hydrochloric acid which is present is converted into sodium chloride salt. Okay, so all the HCl ions should be replaced with the sodium hydroxide, that is sodium ions, thereby converting into salt form, that is called as sodium chloride. So the conductance goes on decreasing. Okay, so next, once after the all the hydrochloric acid completed its reaction with sodium hydroxide, what happens next? Acetic acid is going to get reacted. Okay, so acetic acid gets replaced by a strong electrolyte and sodium acetate is formed as a salt. Okay, so here also, so CH3COO Na is formed. So this this H plus and OH minus will be liberated in the form of water. Okay, so this is what is called as sodium acetate. Okay, so what happens? So since the sodium acetate has got more conductance compared to the acetic acid, so gradually the conductance is going to increase. So when all the acetic acid has also reacted, what happens next? NaOH is going to get accumulated. So since NaOH is a strong electrolyte, so we will see a sharp increase in the conductance. So that is why here we will get a straight line which will be in the manner of increasing conductance. Okay, so 3 straight lines we are going to get here with different slopes. Okay, so 3 straight lines. So this is one HCl versus NaOH, and this is acetic acid versus NaOH, the second straight line, and this will be when NaOH starts accumulating. So this straight line we are going to get. So 3 straight lines we are going to get, and and 2 points of intersections we are going to get. So here the first point of intersection corresponds to the neutralization of hydrochloric acid, and the second one corresponds to the neutralization of both the acids. Okay, so this is the neutralization of both the acids. So by the difference between these two, the difference between the volume of NaOH added, that means so from here till here, the how much volume is used, so that much volume is utilized to neutralize hydrochloric acid, and from here if I subtract it, okay, so from B to C how much volume is used, so that corresponds to the neutralization point of acetic acid. Okay, so this is how we are going to determine the volume required or volume of NaOH added to neutralize acid mixtures. Okay, so this is the principle of the reaction, and next is how to perform this experiment. The experiment is the same how we will do all other cases. So 50 ml of acid mixture should be taken in the beaker, and to that a clean conductivity cell should be dipped in, and 1 normal of NaOH solution is taken in the burette, and 1 ml of it is added to the beaker and stirred well, and the conductance is measured, and addition of successive amounts of NaOH and the measurement of conductance is repeated until at least 3 or 4 readings are obtained after the 2 end points. Okay, so a graph is then drawn with conductance on the y-axis and volume of NaOH on the x-axis. From the graph, volumes of NaOH corresponding to the 2 points of intersections are noted down. Okay, so this is how we are going to determine the conductance of our acid mixture with the help of a conductometer instrument. Okay, and the next case is case 6. This is precipitation titration. So this is also very important, since so this experiment you have in this semester only, estimation of barium. Okay, so estimation of barium experiment number 1. So there you are going to estimate so how much amount of barium is there in the form of barium sulfate. Okay, so this is how you are going to perform the experiment. Okay, that is to estimate the amount of barium present in the given barium chloride solution gravimetrically. So this is a gravimetrical experiment where you are going to convert the barium chloride what has been given to you, so that is converted into barium sulfate, and then you are going to estimate so how much amount of barium is present in the given barium chloride. Okay, so you are going to convert barium chloride into barium sulfate. So that is why, so this is called as precipitation titration, because barium sulfate which is formed, so it gets precipitated out. Okay, so precipitation is going to take place. So how we are going to conduct this experiment, and what is the principle of this experiment? So to understand the principle of this experiment, so let sodium sulfate be pipetted out. Okay, sodium sulfate should be pipetted out into the beaker, and barium chloride should be taken in the burette. Okay, sodium sulfate is taken in the beaker and barium chloride is taken in the burette. And what reaction is going to take place is, when sodium sulfate reacts with barium chloride, so sodium chloride will get salted out. Okay, so it will get converted into salt, sodium chloride, and this barium which is present in barium chloride, that will react with the sulfate ions which are present in the sodium sulfate, thereby converting into barium sulfate. Okay, so this barium sulfate is going to get precipitated out. So till the end point, what happens here is the electrolyte sodium sulfate is replaced by sodium chloride of almost equal conductance. Okay, so the conductance of sodium sulfate and the conductance of sodium chloride is almost equal. So that is why so we are going to get a constant conductance measurement till the end point. Okay, so when this reaction is happening, what happens on the other hand? So barium sulfate is formed and it will be precipitated as undissociated molecule. It will not get dissociated. If it doesn't get dissociated, means it is not at all an electrolyte and it will not carry the electricity. Barium sulfate will not carry the electricity. Barium sulfate means the ions which are present in barium sulfate, that is Ba plus and SO4 minus. So those are undissociated molecules. So that is why the barium sulfate is not going to contribute anything towards the conductance, and hence the conductance practically remains constant till the end point. Okay, so here this straight line and this slope explains the constant conductance which is observed practically till the end point. And once after the end point is reached, so what happens? So next, all the sodium sulfate which was taken in the beaker is completely converted into NaCl and barium sulfate. So there is no sodium sulfate left. So if we continue the titration once after attaining the end point, so then barium chloride is going to get accumulated. Barium chloride is a strong electrolyte. That means it is going to get dissociated into Ba plus and Cl minus. So barium chloride is a strong electrolyte, hence the conductance increases rapidly. So the end point can be obtained by plotting a graph with the conductance on the y-axis and volume of barium chloride added on the x-axis. So we are going to get two straight lines are obtained, and the point of intersection gives the end point of the reaction. Okay, so this is the principle of precipitation titration. And the procedure to this experiment is same. 50 ml of sodium sulfate is taken in the beaker. Barium chloride is taken in the burette. 1111 ml of barium chloride is added in a successive addition way, and conductance is measured. Once after the end point is obtained, 3 or 4 readings extra is performed to get a straight line after the end point, and it is plotted in the graph, and this point of intersection gives the end point or equivalence point. Okay, so next is a titration of salt of weak acid against a strong acid. Okay, so here we are going to titrate a salt. This is sodium acetate, which is already in the form of salt. So this is titrated with hydrochloric acid. Okay, so this is the case 7 which we are going to see under conductometric titrations. So the weak acid salt can also be titrated using conductometer. Okay, so what is the principle? So here the sodium acetate is pipetted out, and we are going to add hydrochloric acid from the burette. What reaction is going to take place is, so here the sodium acetate, when it reacts with hydrochloric acid, so this sodium will get reacted with the chloride, and NaCl is formed, sodium chloride is formed, and this H is going to combine with the CH3COO minus, thereby forming acetic acid. Okay, so this is the reaction what is going to take place. So acetic acid, which is formed as a product, is a weak acid and contributes very little towards conductance. So that is why we are seeing the conductance in a lower way, in the lower measurement. Okay, so conductance is very low here, since acetic acid is a weak electrolyte, and sodium chloride formed has almost the same conductance. Okay, so here the sodium chloride which has been formed on proceeding with the titration, on adding hydrochloric acid to sodium acetate, what happens? Sodium chloride is going to form, and that sodium chloride is having the same conductance, almost the same conductance which the acetic acid also has. So that is why we are not observing any appreciable increase in the conductance. Okay, so what happens here, since the conductance of both acetic acid and sodium chloride is same, so the conductance practically remains constant till the end point. Okay, so this is the end point. After the end point is reached, what happens? So there is no sodium acetate left to react with hydrochloric acid, so that is why hydrochloric acid is going to get accumulated and the conductance increase very rapidly. Okay, so in a rapid rate the conductance is going to increase because hydrochloric acid is a strong electrolyte, so that is why conductance rapidly increases. Hence the end point can be obtained by plotting a graph with the conductance on the y-axis. Okay, so this is y-axis, conductance on the y-axis, and volume of alkali added in the x-axis. Okay, so two straight lines are obtained and the point of intersection gives the end point of the reaction. Okay, so the procedure for this reaction or this experiment is same. So 50 ml of sodium acetate is taken in the beaker and clean conductivity cell is dipped into it, and then hydrochloric acid is taken in the burette. So 1 ml of so before adding hydrochloric acid we should measure the conductance. Since acetic acid is a weak electrolyte, so the initial conductance will be very low, and then start adding hydrochloric acid to that weak acid. Okay, so note down the conductance, and there is no appreciable change in the conductance. That is because the sodium chloride which has been formed will have the same conductance what the sodium acetate will be having. Okay, so that is why no increase in the conductance, so constant values we are going to get. And once after all the sodium acetate is reacted, HCl is going to get accumulated. Okay, so we have to take at least 3 or 4 readings after obtaining the end point. Okay, after obtaining the end point 3 or 4 readings we have to take, and we have to plot the values what has been measured in the conductometer, that is conductance, is plotted against volume of alkali added, and the end point of the titration is obtained. Okay, so these are the different cases which we are going to see in the conductometric titration. Okay, so I am going to stop here, so we will meet in our next class. Thank you.